Hello. So, dear students, we'll be doing 30 MCQs on electrical quantities, and they are covering each and every concept. So, let's solve them. If there is any question, feel free to ask me. Question number 51. Which statement about resistance of a metal wire is correct? Okay, they want to discuss the relationship of resistance with length as well as with the cross-section area. You all know resistance is directly proportional to length, and resistance of wire is inversely proportional to area. You will look for which option is describing these two. The resistance is directly proportional to length, yes, but the resistance is directly proportional to area. The second sentence is wrong. The wrong I'm highlighting with the red color, wrong option. Similarly, if you go for resistance is directly proportional to length, correct. Resistance is inversely proportional to cross-section area, correct answer. Inversely proportional to length, wrong answer. Directly proportional to area, wrong answer. Resistance inversely to length, wrong. Inversely to area is correct. So the only option in which both options are right is B. Question number 52. The circuit shows a light-dependent resistor in a potential divider. A voltmeter is connected to LDR. Before we read the question, let me tell you, LDR, if there is more brightness or light intensity, its resistance decreases. In dark, its resistance increases. The first concept. Second concept is potential divider. Potential divider, we say voltage share is directly proportional to resistance. Voltage share is directly proportional to resistance. More resistance, more voltage share, less resistance, less voltage share. Now let's read the question. They say which row shows the resistance of LDR and potential difference with a specific light level. Let's talk about option A. Bright, more light, less resistance? Yes. Voltmeter reading more? No. Why? If there is more light, there is less resistance. So less resistance means voltage share should also be less. Option A is wrong. B. Option B is bright, high resistance. No. If there is more brightness, the resistance will be low. B is wrong. Option C, dim. Dim means dark. Dark has high resistance. High resistance means high voltage share. C is correct answer. D, dim. Dim means dark. Dark has low resistance. No. In dark, the resistance is high. Option C is the correct answer. Question number 53. Which circuit has a zero reading on the ammeter? First of all, you notice all these circuits have diodes. Diode is a device that allows the current to flow in one direction. The symbol of the diode is just like an arrow. If current flows this direction, it is allowed. If current flows opposite direction, it is blocked. Conventional current always moves from positive towards negative. Let's check which will block and the reading will be zero. Option A. Can it pass? Yes, it will not be zero. B starts from here. Can it pass? Yes, will not be zero. Option C. Can it pass? Yes. Can it pass? Yes, this will also not be zero. Option D. Can it pass? Yes. Can it pass? No. So since current will be blocked here, the reading will be zero. Option D. Make sense? Question number 54. Two 10 ohm resistors are connected in series and parallel. Series means we add them. Parallel two resistors, we do product over their sum. So resistance in series will be 10 plus 10, which is 20. Parallel, their product over their sum, 100 over 20, which is 5. Option is C. Question number 55. 55 is the review question for you for future. Put a star. Whenever you do revisions, you should come back for star questions. The diagram shows a circuit containing a cell, two resistors, a switch, a voltmeter. When the switch is open, the voltmeter reading is 1.5. Okay, switch is open, this is 1.5. Let me tell you what circuit they are talking about. Switch open, so current will go this way. It means this 1.5 is right now for both resistors. 1.5 is for resistor 1 as well as for resistor 2. When the switch is closed, let's close that. Now current will come this way. When you close the switch, it is 2 volt. This 2 volt is now only for, you can say R1, R2. R2. And R1 is not even in the circuit. So it means this circuit blue is something like this. The blue circuit is now something like this, which is 2 volt. So what can you say? If the 2 volt is the total voltage, so this is the battery voltage. And the battery voltage is called EMF. So EMF of the battery will be 2 volts. Why? When you close the switch, it will ignore the resistor R1. Current will not go to the upper resistor. So when you close the switch, when switch will be closed, the circuit will behave like this one. So if it behaves like this, the voltmeter reading is 2. This 2 is the EMF of the battery, which is option C. Question number 56. Two resistors are connected in parallel. 4 ohms and 12 ohms. Effective resistance is also called combined resistance. Total resistance in parallel, you can do R1 times R2 over R1 plus R2, which is 4 times 12 over 4 plus 12, which is 48 over 16, 3 ohms. Question number 56. 57. What is equivalent unit to the volt? Volt is the unit for potential difference or EMF, which is defined as amount of energy supplied per unit charge. Energy unit is joules. Charge unit is coulombs. So 1 volt is equals to joules per coulomb. Option is B. Question number 58. A resistor converts 360 joules energy. Energy is 360 joules. Current, I, 3 amperes. Potential difference, V, 6 volts. For how long there is a current? Means you want to find time. You will think which equation E, I, V, and T. The equation for electrical energy is V, I, T. So if you rearrange, time will be energy over V, I. Substitute energy 360 over V 6 I 3. 360 divided by 18. The answer is 20 seconds. B. Very good. We need to look for the right equation which has all these letters. So it was E is equals to VIT. You rearrange to make the subject T. You get it V over E over VI. You substitute the values, you get the answer B. 4 diodes, each contain, sorry, 4 circuits, each contain 4 diodes. In which circuit is the direction of current in the resistor always from red to black? 4 diodes, this structure is called bridge diodes. What? Bridge diode structure is used for full wave rectification. Whenever you have full wave rectification, opposite diodes should be in same direction. Let's check in which case opposite diodes are in same direction. Option A, these two same direction. The other two, are they in same direction? Yes, they are. Let's check B. Are these two in same direction? Yes. Are these two in same direction? Yes. B could also be right. Option C. Are these two in same direction? No, they are not in same direction. Cannot be a right option. Option D. Are they in same direction? Can't be a right option. We shortlisted two options, A and B. Now, the requirement of the question was from red to black. Red to black. Let's choose A first. If you A, you start from upper terminal. If current starts going this way, then it reaches this end. Which diode it will go? Green or red? Red will block. It is opposite. The green will allow. Where will it go, this current? To the red terminal, because this diode will block. Will it go red to black? Yes. Option is A. Let's check why not B. If you look at B, current starts going this way. It reaches the junction. The blue diode will block. The red diode will allow. Again, blue will block. It will reach here. Current will go from black to red. We don't need. We need from red to black. Option A. Pen in your hands. Question number 60. Diagram shows 6 identical lamps connected to a battery. Which lamp is brightest? The brightest lamp, maximum current. The maximum current is for that lamp which is in series with the battery. So which lamp is in series with battery? The lamp P. Why? Because here total current is coming. Later it will be distributed. All others will get less current. Why? Because current in parallel is distributed, branched. When current is branched or distributed, the other lamps Q, R, S, T, U, they will have less current. So which lamp has maximum current? P. The right option is P. Question number 61. A resistor has a potential difference of 12 volts. Underline, give a symbol V. Current, underline, give a symbol I. What is the resistance? R. Which formula of R is involved with V and I? V over I. Resistance base definition. Voltage is 12. Current is 0.6. 12 over 0.6. 20 ohms. Question number 62. Question 62. There is a current I in resistor of resistance R for a time T. Potential difference PD across the resistor is V. You have current, you have V, you want to find power. You know one of the equation of power is V times I. There is an option C. It's just a formula. Question number 63. A resistor and a battery are connected in series. The value of the resistor is 20 ohms. Potential difference of the battery is this. You have resistance, you have the voltage, you want to find the current. You know Ohm's law says V is equals to IR. So I, the current will be V over R. Voltage is 4. Resistance is 20. 4 over 20. 0.2 amperes. Option A. Question number 64. This question should be a star question in your review list. The diagram shows a battery connected to a potential divider and two lamps P and Q. The slider of the potential divider is moved from point X and Y, X to Y. Which row shows the effect on the brightness of each lamp? First of all, lamp P is always parallel to battery. No matter what is the position of the slider, the P is always getting same voltage as battery. So if its voltage is never changing, the brightness of P will not change. Q. Q is having a potentiometer, a sliding contact. Sliding contact is moved from X to Y. X to Y mean this way. You studied with me potentiometer and potential divider that resistance depends upon length. As the length of the sliding contact will increase, resistance will also increase. You also know potential divider, the V is proportional to R. If the resistance will increase, the voltage share will also increase. So as you are moving from X to Y, the length between X and Y is increasing. So when the length between X and Y will increase, the resistance will increase. Using the potential divider formula, the voltage share is proportional to resistance. So it means the voltage share across the lamp will also increase. So brightness of lamp Q will increase. It becomes brighter. Option C. There is a current I in the resistor for a time T. Current is I. Time is T. Potential difference is V. A student calculates IVT. Actually, I use for you VIT. VIT is the formula of electrical energy. In which unit the student's answer will be there? So energy unit is joules. Option is C. Question number 66. Which statement about identical lamps in parallel is not correct? First of all, you know in parallel has some advantages. What are those advantages of parallel? Advantage number 1, independent switching. Independent switching. Each component can be switched on off independently. Number 2, they all get same voltage share. Number 3, if one goes out, others still keep working. These are advantages of parallel. Now, which one is not correct? If one lamp blows, the other will remain on. Yes, I already told you, it is the advantage. The current in each is different. Since they all are identical, so current should be same because they are identical. C, the lamps can be switched on or off separately. Yes. They have same voltage. Yes. So only wrong option is B.
The point of same potential for all parallel circuits or just for the
All the components which are parallel to each other, they will have same potential difference. Thank you. Question number 67. A uniform circular cross-sectional area. Which statement is correct? This is about the wires. Wires, resistance is directly proportional to length. Resistance is inversely proportional to cross-section area. So, resistance is directly proportional to area? No. Resistance is directly proportional to cross-section area? No. Resistance directly proportional to length? Yes. Inversely proportional to cross-section area? Yes. Option is C. These things directly to length? Yes. Inversely to diameter? No. It should be square of diameter. So that's why D is wrong. It should be inversely proportional to square of diameter. That's why option D is wrong. Make sense? 68. It's a straight line graph between voltage and current, so it means resistance is constant. If resistance is constant, it means the temperature of that specific component is also constant, and it obeys Ohm's law. So let's see what can be deduced from this graph. As voltage increases, temperature increases. Wrong. I told you if resistance is constant, the temperature must also be constant. As voltage increases, the temperature decreases. No, temperature is constant. As voltage increases, the resistance increases. No, resistance is a constant. As voltage increases, the resistance is constant. Yes, option is D. Question number 69. A battery is connected to the circuit. It is switched on for 1 minute. Underline this word. 1 minute mean time is 60 seconds. During that time, there is a current of 0.40 amperes. I. The battery supplies total energy, E. Which row gives the charge as well as EMF? Charge, Q. Charge formula is I is equals to Q is equals to I multiplied by T. I, they gave you 0.40. Time, they gave you 60 seconds. If you multiply them, it's 24 coulombs. Option either C or D. Now they want EMF. Whether it is EMF or it is voltage or PD, they are defined as amount of energy per unit charge. Energy, we know it is 48 joules. Charge, we found 24 coulombs. 48 over 24 is 2. 2 volts is the EMF. Option C. All we have to choose the right equation in order to get the right answer. Question number 70. It's a very easy question. Before you read this question, I want to give you an information. Any switch, component, voltmeter, ammeter, anything next to the battery is called master. Is called master. Master means this is controlling everything. The current in X is the total current, which comes from the battery. Put there, I will take. This is the total current in the battery. So this total current X, later it is distributed. Some goes here, rest goes here. So actually this point, the red point, is called junction. is called junction. We also say the sum of current entering the junction is equals to current leaving the junction. So current entering is from X. So total current of X is equals to total current of Y plus total current of Z. So what current is coming from the battery? X. It is distributed into Y and Z. Let's see which option is right. So what can you say about current in X? It is equals to Y and to Z. It is equal to each? No. It is equals to sum of them. It is less than Y or Z? No. It is equal to sum of Y and sum of Z? Yes. As I already told you, the current at a junction is distributed. So total current is equals to Y plus Z. Clear? Question number 71. It's a very easy question. A student connects the circuit as shown. Which switches must be closed for the bell to ring without lighting the lamp? You want to ring the bell. You don't want the lamp. Yani bell should be on. Lamp should be off. So let's go. Current comes. It should pass through bell and complete the circuit. That's it. So which switches should be closed? 3 and 1. Option B. Because lamp has to be off. Question number 72. We have very few questions in this topic of kilowatt hour. It's a newly added topic in IGCSE physics. I will put a star so that you should review in later. The cost of electrical energy for each unit is 1 kilowatt hour. Kilowatt hour is actually the energy. A heater, whenever you want to deal in kilowatt hour, your power, which is 2,200, should be divided by 1,000 to change into kilowatts. 2.2 kilowatt. Also, the time what they give you should be changed into hours by dividing by 60. When you divide 48 by 60, 0.8 hours is the time. So organize the information. You have the power, 2.2 kilowatt. You have the time, which is 0.8 hours. I will first find the energy. Electrical energy formula is power multiplied by time. So energy will be in 48 minutes, it will be 2.2 times 0.8, which is 1.76 kilowatt hours. Now, my dear students, you need the cost. The cost, they told you, here energy, here cost. They told you if the energy is 1 kilowatt hour, the cost is $0.25. So if the energy is 1.76 kilowatt hour, how much is the cost? $0.44. Option A. So as I told you, whenever I put a star, you need to come back to these questions and review again. Question number 73. Which statement about electrical current in a conductor is correct? Let's read. In DC circuit, the current is gradually decreases along the conductor. There is no evidence that the current should gradually decrease in the circuit. In DC circuits, the free electrons can flow back and forth. No, they only move from negative to positive. B is wrong option. C, in DC circuit, the electric current remains exactly same all the time. It can be changed by temperature, by changing resistance or anything. Wrong. They say always. In AC circuits, the flow of charges changes direction continuously. True. AC is alternating current. Direction keeps changing periodically, continuously. Option D. Question number 74. A piece of metal wire X has a uniform diameter, which is X. This question should be in your review list. Resistances are. A second piece of wire Y is made of same metal, has uniform diameter. Y has double the area, half the length. I gave you a table method. Okay, here area, here resistance. Length, resistance. Double area. Double area means if area is times 2, the resistance will be divided by 2. Half length. If length is divided by 2, resistance will also be divided by 2. Reason. Resistance is inversely proportional to area, but resistance is directly proportional to length. So now focus half because of area, half because of length. So it means your resistance overall is divided by 2 and 2, which is 1/4. Option A. Question number 75. If the area is times 2, resistance will be divided by 2. If length is divided by 2, resistance will also be divided by 2. So divide by 2, again divide by 2, divide by 4. Question number 75. A student does an experiment to investigate the resistance of a metal wire. The graph shows the results from an experiment. Something is increasing and resistance is decreasing. So it means resistance is inversely proportional to something. The resistance is inversely proportional to what? Diameter? Maybe. Length? No. Temperature? Is this metal wire? So more resistance? If temperature is more, also no. Current. Now, my dear students, gentleman is using current. I will cross it. Yeah. Current is inversely proportional to resistance, but resistance is not inversely proportional to current. Let me tell you. Why? If there is more current, I taught you very clearly, there will be more heat. When there will be more heat, there will be more resistance. Current causes the resistance to be more. Now, diameter. Actually, the resistance is inversely proportional to square of diameter. So inverse mean what? If the diameter increases, resistance will decrease. Look, the x-axis, diameter is increasing. The resistance is decreasing. But D is wrong. Whether it is square or no, again, you are not understanding. If diameter increases, what will happen to resistance? Decreases. This is the graph they gave you.
Dr. R is inversely proportional to current.
I already told you no.
Said,
I never said that the R is inversely proportional to current. I taught you multiple factors of resistance. I never told you that if you increase the current, resistance will decrease. Rather, I told you when you increase the current, there will be more temperature. And when there is more temperature, what happens to resistance of a metal? So how it is inversely proportional?
didn't hear my,
You just said that resistance is inversely proportional. It is not. Any other doubt? Are you sure? Students, let me tell you what's coming in your mind. I know that's a very wrong concept. You studied R is equals to V over I. Yes? So you are thinking the resistance is inversely proportional to current. Resistance of a conductor is constant. This tells you the ratio is constant. It's Ohm's law. It is Ohm's law. The other you are thinking, I is equals to V over R. If voltage is constant, if you increase the resistance in a circuit, it can cause the current to be decreased. But decreasing the current, like you have a lamp. You have a lamp. Pay attention, please. This lamp has a resistance, say 20 ohms. Yes? So, using a variable resistor, my question to you is, if you give more current, do you think this resistance of lamp will decrease? No. The lamp has 20 ohms. If you supply more current from battery, do you think the resistance of lamp will decrease? Actually, it will increase. Why? When there will be more current, the lamp will heat up. Due to heat, there will be more temperature. More temperature will cause the resistance to be even more. You understood? Yeah. It was a good question. Question number 76. An electric fire is connected to a 240 volt supply and transfers the energy at a rate of 1 kilowatt. Okay, voltage you have 240. Kilowatt, power is 1000 watt. Time, 1 hour, 3600 seconds. How much charge passes? Charge formula is Q is equals to IT. Problem is we don't have I, current. So let's find the current first. So current I is equals to P over V. We can first find current. So power is 1000 over voltage is 240, which is 4.16667, right? That is the current. Once you got the current, substitute here. So charge is current 4.1667. Time is 3600, which is approximately 15,000. Option C.
What is the power equal voltage times current?
I use that. Power equals to voltage times current. I use that.
Voltage times current.
Power is not voltage times charge. Sorry.
Yeah.
Yeah. Okay. Next question. 77. Two lamps are connected in parallel. Which switches must be closed so that both lamps light up? All switches. To light up both lamps, you need to close all switches. 1, 2, and 3. Question number 78. This should be your review list question. 78. This is a relay circuit. So diagram shows a circuit that switches on lamp when there is a change in environment. Which change in environment causes the lamp to be switched on? I really don't want. We will get the answer from here. Ready? To make the lamp on. Yes? This switch must be closed. Yes? To close this switch, this electromagnet should be very strong. To close the switch, electromagnet should be very strong. For this electromagnet to be very strong, this voltage share should be very high. If this voltage share is to be very high, which is V2, for example, then this voltage share, V1, should be very low. It's a potential divider circuit. If one voltage is to be high, the other has to be low. This voltage share low means this resistance should also be low. Resistance of this thermistor can only be low if temperature of thermistor rises. By the way, it's a very good circuit. Now look, let's go opposite. Let's go opposite. Look at this green color. Number one, if temperature rises, what will happen? Thermistor resistance will decrease. Pay attention, please. If temperature, number one, if temperature rises, number two, resistance of thermistor will decrease. Number three, voltage share of thermistor will decrease. If voltage share of thermistor V1 decreases, number four, voltage share of the relay will increase. More voltage share will make the electromagnet to be very strong. If electromagnet becomes very strong, switch will be closed. When switch will be closed, lamp will turn on. So it's a very interesting situation. I didn't read the option. You can again go to point 1, 2, 3, 4, 5, 6, 7. 1, when temperature rises. 2, thermistor resistance will decrease. 3, the voltage share of thermistor will decrease. 4, the other voltage share will increase. 5, when the voltage share of relay is high, relay will be very strong. 6, strong relay will close the switch. 7, switch closed, lamp will be on. So answer is what environmental condition? Temperature rise. There is a rise in temperature, option D. You understood? It's a good question. 79. You all know that resistance of wire is directly proportional to length. Resistance is inversely proportional to square of diameter. You want smallest resistance. For smallest resistance, the length should be very less length. For smallest resistance, the diameter should be more diameter. Right option is B. And the last question, number 80, is the circuit shown contains 3 switches and 4 lamps P, Q, R, S. Which switches must be closed to light only lamp P and Q? P and R. P, R. Close one. P is on. R is on. Yes. Switch 1 only. 30 questions we solved. Now we proceed to structured questions